Hello guys and welcome back to Gamad, and it's time for the second part in this tutorial series. Today we're going to create the algorithm that will make sure that you will choose a path, then just use that path and just remove all those walls. Anyway, we start with creating a function called public void choose path. Alright, so choose path, we are going to input one variable, and that is vector2 position. So the reason for this is that we got a position of the starting point of a tile. So for example, we got a tile here, we can go forward, right, left and down. So that are the four options. So we're just going to loop through each of those options and just look if we can actually go there. If there isn't anywhere we can go, so all of them are already taken, we are going back. We're going back to the last one, and we're just going to use that one to do the same algorithm and just see if there are any positions left where it can go, and so on. So for that we of course need a direction. So which direction are you going to choose first? Is it going to be up, down, left, right? So what we're going to do is kolonien.order, and this means that we can just put a rotation in like the three variables x, y, z. And we're going to do a new vector3. And what we're going to do is 0, 0, and then the last one 90 degrees multiplied by a random range. And the range is from 0 till 4, which means that it can pick 0, 1, 2, 3. So we can just have each rotation, so we can go forward, right, left, down. We're not doing it right here because this is, well, we use the vector2 and this is just the right variable. So we just use this one. But of course, if you're going to make it a side scroller and you don't want to have the camera at the top of your scene, you probably need to fix this and have the variables a little bit different. Anyway, we got here a rotation, and now we can just multiply by vector2 dot up, and that multiplied by 2. The reason we multiplied by 2 is because our grid works with 2 by 2 by 2, and the vector2 dot up is just because it's like the forward we are going to use. So now we've got a random direction, and well, we also need to know which position it is, and that's actually quite a simple calculation. It's just vector2 next position, and it is the position, so it is the old position of the grid plus the direction where you want to go, and then of course you got a new position. Then we're going to have something that's maybe a little bit strange. We're going to have int random direction, and we're going to say that's 1. And we're just going to have an if statement that if you've got a random range 0, 2, and if it is 1, we are going to say random dir is -1. So the reason we do this is to make sure that you also got a random rotation in which they are going. So for example, sometimes you want them to go clockwise and sometimes not, if they are going towards the next position. The reason we do this is that otherwise a lot of times you get by the sides of the maze that it will just be one long line. If you just make that sometimes it will go clockwise and sometimes not, we just got a bigger chance that will just be the maze will be a lot harder. So if you want to make the maze a little bit easier with some more straight lines, you can just remove this part plus every part where we use the random direction. So now we're going to have a for loop, and probably if you just follow this then you would just think, oh, it is a 4 that needs to be standing here, because we got in total 4 options. So we got 0, 1, 2, and 3. But actually, we are going to have 5 options. The 5th option is that there isn't any option where it needs to go. And if that is, then we're going to say we will go back. So we are keeping track of all the positions where we just have been. And if we just have to go back, we just remove the position where we're currently at, and we're going towards the last positions that is in the list. So, and we're just going to start there the whole algorithm over again. So here we are just going to say that the next position is a new factor2 of the int, and this seems a little bit weird, of course, because why are we just actually copying the same values and just making it an int? The reason we do this is to actually make sure that on the end of the script we are going to rotate it. We are just going towards the next position. For some stupid mistake, Unity doesn't rotate it always fully 90 degrees, but sometimes 90 degrees .00001. What that makes is that this isn't exactly, for example, 2.4, but 2.0001 and 3.99999. That's annoying, because if we want to test which position it is, that can sometimes give some errors. Also, we work further on this, so the next rotation is again, we're going to use this, and then it means we can have another problem, because slowly but surely you'll come further away from the position. So just to make sure that we just keep on the right positions, we just put this int. Then we are going to see if in available positions, so that's all the positions in the grid that hasn't been visited before, if that contains next position, we can just say, well, we just want to set a path, and that's of course a new function. We still have to write that. So set path for the next position, and well, actually we also want to return, because well, there isn't really anything else to do again in this one, because we already got one position where we're going to go. Of course, if we got the last position, we still haven't found anything. We did go to other direction, we are at the last direction again, and it, of course, doesn't got an available position. So we're going to say if I is equal to 4, then again a new script, a new function, go back. So going back, that is a function I will just talk a little bit more later on, but that just makes sure that actually there's always a solution. Then the last thing, the direction, we of course want to set it towards the next rotation. So what we're going to do is kolonien.euler new factor3 of 0,090. So we're rotating it 90 degrees, except we're going to do it multiply it by the random direction. So that means that sometimes it's a minus 90 and sometimes it's 90. But we said it before, we did like the for loop, so sometimes we'll go clockwise and sometimes not. That's the main important thing about this. Then what we're going to do right here is saying we actually want to multiply it by the direction. So we are actually moving the direction. Then we're going to say normalized. We just did it to make sure again that there isn't any weird input, and multiply by 2. So as you can see, there are quite a few lines where the only thing what we're doing, or the most important thing we're doing, is actually also making sure that there isn't any error within the script, and that's not a problem. Even though a lot of times you can just run it right. In older computers, I really mean like the from 2008, and just those bad PCs will get sometimes a little bit trouble with this. This is, I think, already a bug by Unity and it's already known, but just for that we actually do those double checks. So the next position again is going to be the position plus the direction. So now we got everything. This is the whole function of choosing a path. So now we've got a path, so what are we now supposed to do with that path? Well, we are going to set the path. So public void set path. Of course, again we got vector2 position. And this position needs to be right here. So now this is called. Awesome. So very first what we're going to do is if old position dot count is more than 0. So this means actually that the old position is like the list of all the positions where you just have been, and it's also the fastest way from your position to the beginning. And actually if this equal to 0, so the very first path we set, we actually don't want to remove any walls and things like that, because we get errors because we actually don't have two old positions. So that's why we're doing that. So now the very first thing we're going to do is calculate the position of the wall. And for here we actually need those old positions. We don't want any errors because we are going to use, just in a minute, old position and then old position.count -1. Which means that we need to be careful with that. And that's why this if statement is here. So we've got here a new vector 3, and that's of the position x, 0, position I. So this is like the position. Then we are going to edit with a new vector 3 of the old positions, and from that we are just doing like the last position there has been. So for example, you just been to the starting area, so that is like the very first old position. We just went to the next one. This is the location of the old position. So the reason we do this is to calculate what the wall position is, and the wall position is exactly in the middle of those two well, crits or tiles or whatever you want to call them. Which means if we just name the middle of like those two positions, we know what the position is of the wall. So old pos, and again old position dot count -1 dot I, and the last thing we do is multiply it by a half. So now we've got the average, and that's just awesome. If and we want, if you want to use the target camera, like we've got here, this is the position where we want to put it. So the target camera, that was like the transom that's just going towards the position where currently the generation is working. And maybe you don't want it, so, but if you want it, this is like the position where you want to put it, and then you are done. Anyway, here we are going to say the we need to get the wall. For that we need another function. So that's like the last thing we're going to do today. We're going to create that function, and we're just going to finish like this if statement, and next week we're going on with what we're currently doing. So we got a public game object, get wall. So get wall, we're just going to loop through our walls, and we just got the vector3.position, and with that we can just find out where the wall is. So for int e, and we're just going through all the walls we got. If vector3.distance, again this is if the position isn't well exactly right, we just do the distance to make sure that even if you've got like a slight error in it, you will just still get like the right wall. So walls e dot transform.position and the position we want to check. If that is less than a quarter, it means we got the right wall. So return walls E. So we also always get like the right wall from this. If you just trust your system very good and you just think that the system will just take it and you know it will be on good computers, you can always make it a little bit smaller and it will still get the right one. But because we probably also have some old computers, we just keep it a little bit bigger. So not all paths return a value. That's currently the error that is standing here. And we're just going to put here return null. So now we got it. Now we can get the wall we need to have. So game object old wall is going to be get wall from that position. So the wall position. Now the only thing we need to do is actually remove it. So if old wall, which just means we actually found one, because maybe for some stupid reason it didn't work. We don't want it to actually break the whole game, but that it doesn't remove that one wall, well, it sucks, but we can live with it. So walls.remove old wall. So first we remove it from the list, and only after that we destroy the old wall. The reason we do this is that otherwise you'll get an error, because you're trying to access the old wall, but it actually doesn't exist anymore. Anyway, this is like the whole thing we're going to do today. Next week we're going to end the write the whole set path code and also the go back function. So I see you guys next time with the next part in this tutorial series. Bye!